Hi, this video is going to go through the solutions for homework 3. Homework 3, we are trying to compare cancer death rates between 1940 and 1986. We started by calculating the crude cancer death rates for the 2 years. The way to calculate those is by taking the total number of deaths in the population and dividing by the total size of the population. So for 1940, there were 158,200 deaths out of 131,670,000 total people, which gives us a crude death rate of 0.0012, or expressed differently, 120.1489 cancer deaths per 1,000 people in 1940. In 1986, there were 469,330 cancer deaths out of 241,097,000 people, and that gave us a cancer death rate in 1986, the crude rate of 0.00194, or 194.6644 cancer deaths per 100,000 people in 1986. So looking at the crude rates, it appears that the cancer death rate is quite a bit higher in 1986 than it was in 1940. Now the next thing that we looked at was the proportion of the population in each of these age categories in 1940 and in 1986. So to calculate the proportion in each age group, we looked at the population size in that age group for that year and divided by the total population for that year. So for instance, in 1940, in the 0 to 14 age group, there were 32,972,000 people out of a total of 131,670,000 people. We take that division and we calculate the age-adjusted rate. Same idea in 1986 for that age group. There were 52,012,000 people who were between age of 0 and 14 out of 241,097,000 people. And when we do the division, we can kind of keep doing this down the table for each of the populations and each of the age groups and find the proportion of the population from 1940 in each of the age groups, and that's shown here, and the proportion of the 1986 population that's in each of these age groups. Now if we look at this, we can see that for the really youngest age groups, the proportion in the youngest age groups was a little bit lower in 1986 than it was in 1940. There were more very young people in 1940. We can also see, if we look down at the older age groups, that the proportion in these oldest age groups was higher in 1986. So in general, the population in 1986 was an older population than it was in 1940. Next thing we looked at was the age-specific cancer death rates. For each category, each age category, we calculated the age-specific cancer death rates for, say, in the 1940s population by taking the number of deaths during 1940 in that age group. So for the first one, that would be 1,161. And then dividing by the population size during 1940 for that age group. So here it was 32,972,000 people, ages 0 to 14, and we do that division. And we continue that process down throughout each of the age groups. So if we continue that process, we get these age-specific death rates. Similarly, we do the same thing for 1986. Here we're looking at the number of deaths occurring during 1986 in that age category, divided by the population size during 1986 in that age category. So here in the 0 to 14 category, for instance, in 1986 there were 1,831 deaths out of the total population size of 52,012,000. And again, we continue this process and we get age-specific death rates for each of the age categories. Now if we look at them, we can see a couple of things. First of all, we can see that They're not terribly different from year to year if we look across the rows. A little bit different, but not too different. But the other thing that we can see is that they change a great deal with age. People who are older have much higher age-specific cancer death rates than people who are younger. So when we want to compare cancer death rates between 1940 and 1986 to get a sense of, are people at higher risk of getting cancer, or were they in 1986 than they were in 1940, why would we need to standardize? And the answer is we should be standardizing, first of all. And the reason that we should be standardizing is because age distribution differs between the 2 years, and death rates differ by age. Right? We know 1986 had more older people. The higher rates of cancer death are in older age groups. So without standardizing, how can we tell if the reason that we saw more cancer deaths in 1986 as a sort of crude rate is because the population is older, or because there's actually a higher risk at each age of developing cancer? So really, it's because age is related to both the year and to the cancer death rates. It acts as a confounding variable, and we need to standardize in order to make a valid comparison between the 2 years. So we're going to look at the two methods of standardization and applying those. The first is the direct method of standardization. Direct method of standardization requires us to choose a standard population, and I instructed you to use 1940 population as the standard. Now, when we do the direct method, what we do is we assume that the standard population age composition is applied in both 1940 and 1986. So for 1940, to calculate the expected deaths using the direct method, we take the standard population that's in that age category. So for instance, for this first one, let's say, okay, I've got 32,972,000 people, and I multiply it by the age-specific death rate for 1940. So here I'd multiply these two. But notice that because 1940 is being used as the standard, when I do this multiplication, I'm taking the population in that age at 1940, I'm multiplying it by the number of deaths in that age group in 1940 divided by the population in 1940. These two, the population cancels itself out here, right? And so all I have is the number of deaths that actually occurred. So the expected number of deaths in 1940, because we're using 1940 as the standard, are going to be the same as the actual observed deaths that year. Right? So when we do the adjusted rate, we take the total number of expected deaths and divide it by the total population size. But since these are the same as what was actually observed, our adjusted rate is exactly the same as our crude death rate was. 120.149 cancer deaths per 100,000 people. When we apply this to 1986, we take the standard population in the age category. So again, these are coming from the 1940 population, that was our standard. And we multiply each of these population sizes by the 1986 age-specific death rate. So for instance, I take the standard population size in the 0 to 14, I multiply it by the age-specific rate from 1986, and I get an expected number of deaths in this age group if the population in 1986 had the same composition as in 1940. And I continue down through to do these calculations. Once I apply all these age-specific rates to the standard population, I figure out the total number of expected deaths. I divide that by the size of the standard population, and that gives me my age-adjusted cancer death rate, which is, for 1986, 133.8943. So, per 100,000 people. We can see that this is still higher than the rate of about 120 per 100,000 people that we saw in 1940, but it's much closer than we saw when we compared crude rates. Remember, the crude rate for 1986 was 194 per 100,000 people, so this is much closer comparison once we control for age. We'll also look at the indirect method of adjusting these rates. The indirect method, instead of using the standard population composition age-wise, we're going to use the actual population composition from each of the 2 years and apply the cancer death rates that are age-specific from the year 1940. So here in both cases we're using the same age-specific rates, which are our standard ones from 1940. We're multiplying for 1940, taking the size of the population in that age group in 1940 times the standard age-specific rate, which came from the 1940 population, remember. So because of that, once again, we're taking the population in 1940 times the number of deaths in 1940 in that age group divided by the population size in 1940. Again, these cancel out, and the expected number of deaths are the same as the observed number for that year. And this is only because we're using 1940 as the standard. Once we figure out the expected number of deaths, we take the total expected number of deaths, and we use it with the observed total number of deaths to find the standardized mortality ratio, SMR. So to calculate that, we take the observed number of deaths in 1940, divided by the expected number of deaths in 1940, and we get a ratio of 1. Then to use the standardized mortality ratio to find the age-adjusted cancer death rate, we multiply that standardized mortality ratio by the crude rate from the standard population. Remember, that was 1940, and the crude death rate due to cancer in 1940 was 0.00120. And so when I multiply those two together, 1 multiplied by this gives me the same same adjusted rate as I had in my crude rate. So the age-adjusted rate for 1940 is 120.149 cancer deaths per 100,000 people. When I apply this to 1986, again, I'm using the real population composition from 1986, but I'm using standard age-specific cancer death rates, which came from 1940. So I'm kind of saying, okay, if the population had the makeup that it did in 1986, but the cancer death rates that occurred in 1940, how many deaths would I have expected to occur? I'm multiplying the size of the population in each age group by the standard age-specific rate to figure out the expected number of deaths. And once I do this for all the age groups, I again calculate the standardized mortality ratio for 1986 by taking the total number of deaths that occurred in 1986, which, if you remember back from the beginning, was 469,330. I divide that by the expected number of deaths, 412,761.9021, and I get a standardized mortality ratio of about 1.137. So what this is kind of telling me is that, okay, if it's greater than 1, it means I saw more deaths than I would have expected. Now, when I use this to calculate the adjusted rate, I again take the standardized mortality ratio, multiply it by the crude rate in the standard population. So there's my standardized mortality rate. Here's the crude rate in 1940, because that was my standard, and I get this age-adjusted rate. So the age-adjusted cancer death rate in 1986 is 136.615 cancer deaths per 100,000 people. So if we want to think about comparing death rates between 1940 and 1986, when we looked at the crude rates, there appeared to be a much higher rate of cancer death in 1986 compared to 1940. However, after adjusting for age, the cancer death rate was only slightly higher in 1986 than 1940. So in fact, the sort of risk that a person had of developing cancer in 1986 was only very slightly higher. Hopefully this helped you better understand the homework. If you find you still have questions, please let me know. Thanks.